Good day everyone, welcome to another video tutorial. Today we're going to tackle placing figures in coordinate plane. This will be in preparation for us in the topic of coordinate proof. In this lesson we will be tackling or we will be practicing placing figures, triangle figures. So let's start. These are the guidelines for placing figures on the coordinate plane. So first is we need to use the origin as a vertex or the center of our figures when we place it. Second is we need to place at least one side of the polygon on an axis. Either x-axis or y-axis will do. Number three is we should keep the figure in the first quadrant if possible. This will help us deal, this will help us in dealing with positive numbers. Number four, we use the coordinates that will make computation as simple as possible. For me, I prefer to deal with even numbers than fractions. So I will show you how that works later. Now I have the following figures here of placing a triangle in a coordinate plane, most specifically in the first quadrant. Now I would like to ask you which of the following figures or which of the following illustration will make our our coordinate proofs the simplest. So, okay, so if you choose this one, then you're right. This one, the no vertex was placed on the origin and no side of a polygon was placed on an axis. This one vertex was placed on the origin, but none of the sides of a polygon was placed on the on an axis. This one as well will not be suit for simplifying the coordinate proof. So the answer would be this one. Okay, let's try placing figures in the coordinate plane. Let's start with with an isosceles triangle. One characteristic of an isosceles triangle is that this triangle has two equal sides. So let's place the triangle in a coordinate plane. As you can see, one of its one of the vertex is placed on the origin. One side was placed on an axis, more specifically the x-axis. Now, since this is an isosceles triangle, we need to consider in writing a coordinate here that this side and this side should be equal because that is the meaning of an isosceles triangle. So, the very first thing that I will be doing is to use the coordinates of the origin as 0, comma 0. So, because this is the origin, so that is 0, comma 0. Now, I will be using this one. I will be putting the coordinates of this one. Now, this lies on an axis, same as with this point. So, technically, the value of y here should be 0. Now, the problem is, what will be my x-axis, my x coordinates? You see, here in number 4, we are instructed to use a coordinates that will simplify the computation. I could just write here A or any other letter, but that would be good. But if I will be using A and this one lies in here or a line here, so the value for x here should be 1/2 of A. So this will be, the coordinate for this will be A over 2, comma 0. So that won't make any sense. This will make sense, I'm sorry. But if I'm going to use this in my coordinate proof, in distance formula, midpoint formula, and slope formula, I will be dealing with a fraction. Now, to get rid of it, why not? I will be using 2a. Using 2a, this will make my computation much easier. Because if I'm going to give a coordinate for this point, this will become a comma 0. So from this point to this point is A, from this point to this point is A as well, so that will be give us 2A. Now we have two coordinates that we supply. Now this one is essential as well. Remember that this part of the the Cartesian plane is A. Now this one, I'll be using the coordinate of B or the measurement of B on a y-axis. So it's up to you what letter you're going to use. You could use just 3A, but for me, I'll be using B. Now to get the coordinate of this point, I'll just use the y coordinates and x coordinate and we name it AB. So now this is how I place an isosceles triangle on a Cartesian plane. And it follows all the guidelines here. Now remember, in order for us to prove that our placing is correct, we need to prove that this is an isosceles triangle. So how can we be proving that this is an isosceles triangle? Again, we need to prove that this side and this side is equivalent to each other. Now, if we're going to find the measure of this side, the measure of this is 2a. You can do that by getting the distance from this point to this point. We'll just be using this one, the absolute value of x sub 1 minus x sub 2. So our x sub 1 is, let's see, 0 minus 2a, and that is equal to negative 2a, and the absolute value of negative 2a is 2a. So this is 2a. So now we need to know what is the measurement of this side, these two sides. And if they are equal, then this is an isosceles triangle. Let's use the distance formula between 0, comma 0 and a and b to get the distance of this one. So if you have problem or if you don't know what is the distance formula, you could visit my previous videos on how to get this. So let's identify our point 1 and point 2. Let's use the distance formula. After using the distance formula, let's substitute all the values. So this is for a sub 2 minus 0. They have b minus 0 as well. So let's simplify it further. We have a squared plus b squared. So this will be the distance of this point. On the other hand, let's get the distance between this point and this point. So this will be point 1 and point 2. Again, use a distance formula. Substitute the given that we have, 2a minus a, then 0 minus b. So in this case, 2a minus a will become a squared. 0 minus b will become negative b squared. Now if we simplify this, this will give us the same, this value. So since the two sides of the triangle are congruent, therefore the triangle is an isosceles triangle. So that's how we prove this. So meaning our placing of figure is correct. Now how about right triangle? Now with the right triangle, one angle of this is a right angle. So we need to just write it in the Cartesian plane. Be sure that these two sides are on lie on the x and y axis. This will make our computation easier. Again, let's mark all the vertices. Let's just name all these vertices. So this one will be 0, comma 0 because this is obvious. This is the origin. Now in this point, I don't have any points to deal with here. So there's no point to mark here. So that's why I just use A. And for this point, there's no point between these 2 points that I should be concerned of. That's why this point will become 0, comma B. So now to prove that this is a right triangle, we need to come up with the Pythagorean formula, meaning this is A, B, or C, and we need to have the formula of C is equal to A squared plus B squared. Let's see if that is correct. So by the way, the distance from this point to this point is A. this one. And the distance from this point to this point is B. So let's see what is the distance in this one. Now, to find the distance from A to Z to C, we'll be using the distance formula. So we'll be using point A and point B. So just substitute the values that we have. A minus 0, then plus quantity 0 minus B. This will yield to A squared. This will lead to negative B squared. If we simplify this, we'll be having this as a equation. As you can see, this is the formula for, this is the Pythagorean formula to get the hypotenuse of the right triangle. So therefore, this is correct. Again, on the guidelines, it says there that at least one side is placed on the coordinate in the axis. So meaning a right triangle could be placed like this. But the question is this will be a right triangle? So let's try to solve it once again. 0, 0. Now remember, the distance from 0 to here, I will be putting B. So that's why this, if this is B comma 0, this will be A comma B, 0 comma B, I'm sorry. This will become A comma B because this should have the same x coordinate, but the height should be B. Now let's use the distance formula to prove the same properties. So this will be our point 1 and this will be our point 2. The hypotenuse should have the same formula or the same distance as the Pythagorean formula. So let's substitute the given and that will give us the same formula as well. So now we just place a right triangle on a Cartesian plane. Next is the equilateral triangle. The equilateral triangle is a triangle that has four equal sides. Since we're dealing with a Cartesian plane here, we need to make some statement or assumption first. We need to state that 2a will be equal to the square root of a squared plus b squared. Because it will be hard for us to prove that this one will be equal to this one and this one. That's why we need to make this assumption. So again, I placed a figure at the middle, meaning that the vertex should be 0, no vertex was placed on the origin. This is also acceptable for some of the case, but you could just do the same on how we place the isosceles triangle. But I will try this one for this example or this problem. So this will be 0 and B. If you're going to ask where does B come from, you will be decide on what is the height of this one. So me, I decide that this will be B. Now, since this one from here to here is A, and this is the middle of the triangle, so the measurement of this is A. So therefore, the measurement of this is A. But since the distance from the point to 0 is A, and we need to find the point here, or the coordinates here, and it is on the left of the origin, therefore the distance of A here should be negative. So this it will be negative A comma 0. So now we have all our vertices. Now let's see the distance of AC and AB. So that will be the same. AC and AB will have the same distance. So this is how we place an equilateral triangle on a Cartesian plane. Now we're going to answer maybe some Q questions, or we're going to prove some questions using what we've learned in this lesson. We will, in this problem, write the coordinate proof to show the line segment joining the midpoint of two sides of the triangle is parallel to the third side. First things first, we need to place a triangle. It doesn't necessarily mean what kind of triangle. Any triangle will do. For this illustration, I will be writing this triangle. This is a triangle. It doesn't say if it is equilateral, isosceles, right, or scalene, as long as it is a triangle. Now, what I'm going to do is I'm going to prove that the midpoint of this one, from this one to this one, and the midpoint of this one, if I connected them, it will be parallel to this side. So that's what I'm going to prove. So let's first mark the vertices of the triangle. So this will be A, B, and C. So this will be 0, 0, comma 0. Now, since there is a point that I'm be concerning at the middle of this one, it would be wise to use 2A here. So 2A, comma 0. Now, since we will be getting the midpoint of this two, meaning we'll be having to consider point at the middle of these two lines, these two sides of the triangle. So I will not be using B here because if I get to divide B, that would be B over 2. So I'll be using 2B here and 2C. Now, where does 2C here, 2C? So where does this 2B come from? So 2B is the coordinate of this 2B. And the center of this will become B. And I just assume that this from this point to this point is 2A. It doesn't really matter if that's the case, as long as your coordinates will make you compute for the or to prove the properties easily. So I hope that you understand that. So let's get the midpoint of this one. What is the coordinate of this one? Now to get this, we'll be using this one and this one. And that would be the midpoint is you add this 2b plus 0 divided by 2. That is 2b over 2, and that is b. So this is the coordinate for this one, the x coordinate for this one, b. How about 2c and 0? So 2c plus 0 over 2. So that is 2c over 2. Cancel this so that this will be c. So the coordinate midpoint for this one is b comma c. Okay, now let's get the coordinate midpoint between this one and this one. Let's start first with the x coordinate. So that is 2b plus 2a over 2. So we cannot, these are unlike terms, so we can combine them. We could just divide it by 2. So this will become 2 multiplied by b plus a over 2, then cancel 2. That will become b plus a. Or we could just do a plus b. So this will be our first coordinate, a plus b. Next is 2c plus 0. 2c plus 0 over 2, this is 2c divided by 2, so that is c. So the coordinate for this is a plus b comma c. Okay, that's it. Now we know that they share the same y coordinates because it is c and it is c. Now we know that the distance from this point to this point is b. Now all we need to do is to add the distance of a to get the b or a plus b. So that's how good it is. Meaning that this one is a. So from here to here is a, from here to here is a, so that is it becomes 2a, or maybe not. Okay, now let's prove if this is parallel. To prove that this is parallel, all we need to do is to use the slope formula. Let's use the slope, or let's compare this one into this one. Let's use the slope formula for that. This is the slope formula. Y sub 2 will be c plus minus c, and the x sub 2 is a plus b minus b. That gives us 0 over a, or slope 1 is 0. Now let's use the slope of this one and this one. Okay, let's substitute the value. We have this one or this one. So since both slope is 0, or slope 1 and slope 2 is equal to 0, therefore the line segment joining the midpoints of the two sides of the triangle are parallel to the third side. So if that is parallel, so we just prove the problem using the coordinate proof. Okay, so that's all for placing triangles in coordinate planes. I hope that you learned something from this tutorial. And on the next lesson, we're going to place a quadrilateral on a Cartesian plane. So see you on the next video tutorial. Bye-bye.